Hi, this is Priyankesh. I hope you all are doing great. This is the third trial class, and this we are going to cover the remaining topic of differentiation. Let's get started. So, coming to the syllabus, till now we have covered this much portion. Okay, now we have to cover only these two topics. So, let's begin with the application of differentiation first. So in the application of differentiation, we're going to talk about first tangents and normals. Okay. So suppose we have any curve, let's say y equals to fx in the form of y equals to fx, and we have to find out the let's say slope of the tangent or the slope of the normal. So what we have to do, we have to differentiate this function with respect to x, and we'll get f dash x. So this will represent the slope of tangents. Okay, this will represent the slope of tangent. In order to find out the slope of normal, what will I have to do? So the slope of normal will be minus 1 upon dy by dx. Okay, so this will represent the slope of normal. Okay, now what is normal and what is tangent? So let's say we have a curve, this y equals to fx. So tangent is any line that is touching the curve at one point or intersecting the curve at one point. And normal is the perpendicular line on tangent. Okay, keep this thing in your mind. Normal is the perpendicular line on the tangent. It is not a perpendicular line. Okay, so remember this thing. Okay, so this represents your normal and this represents your tangent. Okay, and this is your point of contact. Point of contact. So remember this thing. Okay, now let's move ahead. So we have to find the equation of tangent and equation of normal. So we should have a point of contact. Let's say the point is x1 comma y1. So the equation of tangent will be equals to y minus y1 equals to dy by dx at x1 comma y. Okay, and then in another bracket we have x minus x1. Okay, so that is the equation of tangent. Now let's move to the equation of normal. Okay, what we have to do, equation of normal. So it is again y minus y1, and here in the place of slope you will put the value of slope of uh, what? Slope of normal. So this will be minus 1 upon dy by dx at x1 comma y1, and in a bracket you have x minus x1. Okay, so let's understand this by an example. So let's take the example one. So suppose we have a curve. Let's say this is the curve, that is x to the power 2 by 3 plus y to the power 2 by 3 equals to 2. And let's say we have a point that is 1 comma 1. Now we have to find out the equation of tangent. Okay, so in order to find out the equation of tangent and normal, suppose we have to find this. Okay, equation of tangent and normal. So this is our agenda. Generally, this kind of question is being asked in IGIDR Entrance Exam. Okay, so what we'll do, we are going to do here. First, we'll differentiate this curve with respect to x. So this is coming out to be 2 by 3 x to the power 2 by 3 minus 1 plus again 2 by 3 and then y to the power 2 by 3 minus 1. Then the differentiation of y will be y dash. Okay, and here the differentiation is 0. So we can take 2 by 3 as common and shift it onto the right hand side, it will become 0. So y dash is coming out to be minus x to the power minus 1 by 3 and y to the power minus 1 by 3. Alternatively, we can write it like that, y upon x to the whole power 1 by 3. Okay, so now we have to find out the value of slope at point 1 comma 1. So this will coming out to be what? 1 comma 1. This will come out to be minus 1. Sorry, this is 1 upon 1. the whole power 1 by 3. So this will come out to be minus 1. This is nothing but slope of tangent. Okay. Now the slope of normal will be slope of normal. This is nothing but 1 upon y dash at 1 comma 1. Okay. So this is minus 1 upon minus 1. So it will get cancelled out and comes out to be 1. Now to find out the equation of tangent, we have point and we have slope. So this will come out to be, the point was 1 comma 1. Okay. So this will come out to be y minus 1 and the slope is minus 1 and in a bracket x minus 1. Okay. So here what we are going to get, if you solve this, you will get minus x plus 1. So this will come out to be x plus y equals to 2. This is your answer. Okay, now to find out the equation of normal, this will come out to be y minus y1, that is 1, and the slope is 1, and in a bracket x minus x1. So this will come out to be y minus 1 and x minus 1. Minus 1 gets cancelled out. This will come out to be x minus 1 equals to 0. So this is your answer. Now let's take another example to understand this. Let's take this as example 2. Okay. So here you have curve, that is y equals to x cube minus 11x plus 5. Okay. And suppose you have tangent. Okay. That is y equals to x minus 11. And they are asking about point. Find out the point at which this line is going to be the tangent of this curve. So this kind of question can also be asked. So you have to solve with this thing. Okay. So let's take the point. Let's take point is x1 comma y1. Okay. So here what we are going to do first, we are going to find out the differentiation of the curve. So that will come out to be y dash and this will be 3x square minus 11. So this is your slope, let's say m1. And because this is a slope of tangent and we already have a tangent, so if we compare this line, let's say this is equation 1, this is equation 2, and this is equation 3. Okay. So from 2, from second equation, if we compare this equals to y equals to mx plus c, so we are getting m as 1. Now m and m1 should be same because these are the slope of what? Tangent. So this comes out to be 3x square minus 11 equals to 1. So this is 3x square equals to 12 or x square equals to 4. So x will come out to be plus minus 2. Okay. Now corresponding each x, you are going to get the values of y. So in order to find out the value of y, you can put it in any equation. You can put it either in 1 or either in 2. Both will give you the same values. Okay. So let's take it. So this will let's say n x equals to 2. So y will come out to be here if we are using the equation 2. So that equation was x minus 11. Okay. So we can put it. So this will come out to be minus 9. Okay. And another point could be minus 2. And here it is x minus 1, that is minus 2 minus 11. So this will comes out to be minus 13. Okay. So that is the thing. So one thing I would like to tell you that here we have only one point, because if you check this point, if you just check this point with the alternate equation, let's say this curves equation. So the equation of curve is y equals to x cube minus 11x plus 5. Okay. So let's put x equals to minus 2 here. What we will get? We should get minus 13, but let's see what we are getting here. Y square minus 11x, 11 into minus 2 plus 5. So this is coming out to be 4 minus, this will come out to be 4 plus 8. Here it is cube, right? It has to be come out to be minus 8 plus 22 plus 5. So this is coming out to be 27 minus 8, that is 19. So this x equals to minus 2 and y equals to 19. These 2 points are not same. So this will not be the point of contact. So we have only one point that will be 2 comma minus 9. Okay, so this is your answer. And let me explain you this with the help of graph as well. So here you can see that what we have, uh, this equation represents the graph, that is y equals to x cube minus 11x plus 5. Okay, and this line represents to the y equals to x minus 11. Okay, so you can see that we have only one intersection point, that is corresponding to this point corresponds to 2 comma minus 9. And as we move ahead, either we are getting, here we were getting 1 point, we were getting minus 2 and minus 13, so which is not possible because it is not lying on the curve, and it is lying on the point, line, but it is not lying on the curve. Here this minus 2 comma 19, this point is lying on the curve but not lying on the line, so we have only 1 point here. Okay, now let's move to the next question. So in next question we have, uh, this is example 3. So here we have given one curve, that is x square plus y square minus 2x minus 3 equals to 0. And they are asking about, they are saying that tangent is parallel to x-axis. Okay, they are saying tangent is parallel to x-axis and we have to find out the points. Remember this thing, they are asking about the points, so we will get 2 points here. Okay, so since the tangent is parallel, so any line which is parallel to x-axis have equation. Let's say this is distance a, so this will represent y equals to a. Okay, and it can be here also. So if let's say this is the same distance minus a, so this will come out to be minus a. So both the equations are possible. Okay, so in order to find out the points, what we have to do, we have to differentiate this curves equation. Okay, this curves equation, so this will come out to be 2x plus 2y into y dash minus 2, then differentiation of x is 1 and differentiation of 3 is 0. So we can eliminate 2 by taking common from all the terms. So this will come out to be x plus y dash minus 2. So here y dash will come out to be, no, sorry, here this will come out to be 1 and this will come out to be 1 minus x upon y. Okay, so this is representing the slope of the tangent. This is representing what? Slope of tangent. Okay, now we have tangent is in the form of y equals to a is nothing but some constant. So here if you differentiate, so this will come out to be 0. This is again the slope. So this slope and this slope should be equal. So let's equate it equals to 0. So 1 minus x upon y equals to 0. So this implies that 1 minus x equals to 0. This implying x equals to 1. Okay, so this is the thing. Now, in order to find out the value of y, we have to put this value of x equals to 1 in equation. This is 1. So in equation 1. So at x equals to 1, this is x square plus y square minus 2x minus 3 equals to 0. Okay, so now let's put it. So this is 1 square plus y square minus 2 into 1 minus 3. Okay, so on solving, we'll get minus 5 and here it is 1. So this will minus 4 equals to 0. So y will come out to be plus minus 2. So we are getting 2 points, 1 comma 2 and 1 comma minus 2. So let's understand it by graph. So here you can see that we have two tangents. This is one. Okay, this is what? This is y equals to plus 2 and this is y equals to minus 2. The equation of curve represents what? This represents a circle. Okay, so remember this thing. Here we are getting 2 points. At the point of contact, these two are the point of contact. This will be 1 comma 2 and this will be 1 comma minus 2. Okay, so these 2 points will be your answer. Okay, now let's take another example. So of tangent. So in this, let's say this is example 4. So in this, what we have to do, we have to find the equation of tangent. Okay, equation of tangent, and we have curve equation, that is y equals to x cube plus 2x plus 6. Okay, and we have tangent, we have a line, equation of line. This is x plus 14y plus 4 equals to 0, and this line is perpendicular to, this line is perpendicular to tangent. Okay, here it is, this is given. So I would like to tell you one thing. If if two lines are two lines are perpendicular two lines are perpendicular, so in that situation, the product of their slope, let's say this is the slope of first line and this is the slope of second line, will be equals to -1. So we are going to use this condition. Okay, now what they are asking to find out the equation of tangent, because we have curve, we have equation of line which is perpendicular to tangent. So what we are going to do, we can find out the slope of the tangent with the help of curve, and we can find out the slope of this perpendicular line with by differentiating this. Okay, so let's take, this is equation 1, this is equation 2. Now differentiating equation 1, so we will get y dash equals to 3x square plus 2, and differentiating equation 2, we will get 1 plus 14 y dash equals to 0. Here we are getting -1 by 14. Now by this condition, what we can do, 3x square plus 2 into -1 by 14 equals to -1. Okay, so you can multiply, this minus and minus gets cancelled out, so this will come out to be 3x square plus 2 equals to 14. So this is 3x square equals to 14 minus 2, so this will come out to be x square equals to 4. So x will come out to be plus -2. Now to find out the value of y, we have to put this point on this curve. Okay, so this will come out to be y equals to x cube plus 2x plus 6. So here we are going to put the value of 2. So we are going to get two values of y. So at x equals to 2, y will come out to be 2 cube plus 2 into 2 plus 6. Okay, so this will come out to be 8 plus 4 plus 6. So this is coming out to be 18. So point is 2 comma 18. So this will be the point, first point. Okay, this will be the first point. Okay, now at x equals to -2, this will come out to be y minus 2 cube plus 2 into -2 plus 6. Okay, so this will come out to be -8 minus 4 plus 6. So a minus 8 minus 4 will minus 12, and this will come out to be -6. So the point will be -2 comma -6. So here we are going to get two equation of tangents at these points. Okay, this point and this point. The first equation of tangent will be at this point, so this will come out to be y minus 5, and that is 18, and the slope in the previous part I have shown you, this is the slope. So at the place of x, we will have to put 2, so this will be 2 square plus 2. Okay, and in a bracket, this will be x minus 2. Let's solve it. So this comes out to be here. This comes out to be 3 into 4, 12 plus 2, 14x minus 28. So this will come out to be 14x minus y. And here when we'll shift 18, so this will come out to be minus 10 equals to 0. So this will be our first equation, and equation 2 of tangent we will get at this point. Okay, so this will come out to be y minus y1, that is y plus 6. The slope will be 3 into -2 square plus 2. Okay, and in this bracket we will get x minus x1, that is x plus 2. So this will be y plus 6, and this will be 14, and we will multiply by x plus 2. So this will come out to be 14x plus 14 to the 28. So this will come out to be 14x minus y, and when we'll shift 6 here, so 28 minus 6 will come out to be what? This will come out to be 22. So these two will be your equation. Okay. Now let's move to the next topic, that is maxima and minima. Okay. So this is very important topic because generally two kind of questions is being asked. One is finding out local maxima and local minima. Okay. And next kind of question that is being asked is finding out the maximum value and minimum value and minimum value. So in order to solve these questions, we use two kind of tests. One is called first derivative test. Okay, first derivative test, and second is called second derivative test. Second derivative test. Okay. So for solving such question, what we do, uh, we are not going to into detail about what is first derivative and what is second derivative. I'll explain you with the help of example. Okay. So let's take an example one. So suppose we have curve. Let's take this is fx and the value is x cube minus 6x squared plus 9x minus 8. Okay. So you know how to differentiate this function. So let's differentiate it, find out the first derivative. So this will come out to be 3x square minus 12x plus 9. Okay. Now what you have to do, this is the first thing. Now you have to equate equals to 0. So let's take 3 as common. This will come out to be x square minus 4x plus 3. Okay. Now by midterm splitting method we can solve it. So this will come out to be x minus 3 and x minus 1. Okay. So here we are getting 2 points, that is 3 and 1. So these are called critical points. These are called critical points. Okay. After finding the critical point, what we have to do, we have to draw a number line by marking this point. So let's say this is 1 and this is 3. Okay. And this is minus infinity and this is plus infinity. Now we have to assess the nature of this derivative between these ranges. So let's take any value. Let's say if I take 0 in this range, so if you put 0 here, so this will come out to be positive. So here this is positive, and if you check, let's take 2, so again this will come out to be negative. Okay, and if you check in this range by taking, let's say we take 4, so this will comes out to be positive. Now, to determine whether it is a local maxima, we have to determine at these 2 points. Okay. So, if you can see that this function is changing from negative to positive. Okay. So, ideally, a function will be in this shape. Okay. Because here you can see that initially it was increasing, now it is declining. So, this point will give you what? Local maxima. So, this point will give you local maxima. Okay, and here you can see that here this is moving from negative to positive. So curve will be probably like that, initially decreasing, then it is increasing. So this point will give you local minimum. So 3 will give you local minimum. Okay, so this is the approach to solve the question using first derivative test. Now let's move to the question number 2. It is fx equals to x minus 1 cube and x plus 1 whole square. Okay, so we'll solve it by product rule, that is first and second. So let's see f dash x equals to differentiation of we'll write first function as and differentiation of second function, it will come out to be 2x plus 1 whole power 1. Okay, then we'll write here second function as it is and we'll differentiate first function, so that will come out to be 3x minus 1 whole square. Okay, now we can take x minus 1 whole square and x plus 1 as common. Okay, so it will come out to be in a bracket 2x minus 2. Okay, then plus 3x plus 3. Okay, so finally it is coming out to be x minus 1 whole square and x plus 1, then in bracket it is coming out to be 5x plus 1. Okay, so when we will equate equals to 0, so this will come out to be 1 minus 1 minus 1 by 5. So now we will draw the number line. Okay, So this will go from minus infinity to plus infinity. Now we'll plot the points. So 1, this will be from minus 1, minus 1 by 5, and 1. Okay. Now if we look at the uh, range, nature of range, so here it is will be positive, this will be negative, and this will be positive, and this will be positive. You can check it by taking any value. So I've already checked it. So here uh, now we have to take any point. Look at the nature. This is moving from positive to negative. So this x equals to minus 1 will be a point of local. So look at the graph. See, initially it is increasing, then it is decreasing. So this point will represent the point of local maximum. Okay. Now let's take x equals to minus 1 by 5. So here you can see that it is moving from minus to positive. So graph will be like that. Initially it is decreasing and then it is increasing. So this point will represent point of local minima. Okay. Now let's take point of local minima. Now let's take here it is moving from positive to positive. So in this situation, when it is moving from positive to positive, so this will represent point of inflection. Okay, remember this one thing that if it is moving from positive to positive and negative to negative, it will be a point of inflection. Okay, so this is our answer. Okay, so let's move to the next question. That is question number 3. So here we have question number 3. So in this question we have fx equals to 2x cube minus 21x square plus 36x minus 2, and here f dash x will come out to be 6x square minus 42x plus 36. Now we can we'll have to differentiate, equate it equals to 0, take 6x as common, so this will come out to be x square minus 7x plus 6 equals to 0. Now we can solve it by splitting method. So this will come out to be x minus 1 and x minus 6 equals to 0. Okay. So here x is coming out to be 1 and 6. Okay. Now let's solve it for second derivative. So f double dash is x will come out to be 12x minus 42. Okay. Now we have to assess the nature of the f double dash x at x equals to 1 and at x equals to 6. So let's check it. Okay, so here at x equals to 1, it will f double dash 1 will come out to be 12 into 1 minus 42, so which is less than 0. So this will represent point local maxima. Okay, and at x equals to 6, f double dash 6 will come out to be 12 into 6 minus 42, which is greater than. So this will represent local minima. Okay, remember one thing, this is my trick, that is make mal. Here it denotes if it is greater than, if it is greater than. Okay, if it is greater than, so it will be minima, and if it is less than, it will be maximum. Okay, so you can also remember it by using this code if you want. Okay, so if it is, now let's talk about the next topic, that is partial differentiation. Okay, so in partial differentiation, so here we are going to, let's say we have a function z equals to fx comma y. So we have to find two things. First is partial differentiation. First is partial differentiation, and second is first is partial differentiation, and second is total differentiation. Okay, so for partial differentiation we have to find zx. Here zx denotes the zx and zy. Okay, so zx denotes the partial derivative of z, partial derivative or of z with respect to x, and keeping y constant. Okay, keeping y constant, and then as constant, and then we have zy, that is partial differentiation of z with respect to y, keeping x as constant. Okay, so that is the thing. Now talking about this is first thing. This is second thing is total differentiation. So for total differentiation, we have equals to dz equals to zx into dx plus zy into dy. Okay. So sometimes they might ask you to find out the dz with the help of partial differentiation. So let's take an example. So this is example number 1. This is fx comma y equals to, let's say we have 6x cube plus 7y. Okay, and this denotes the z, and z equals to, let's say, 6x cube plus 7y. Okay, so we have to find here y equals to fx is also given, that is 4x cube plus 3x plus 8. Okay, so we have to find, let's say, dz by, sorry, it should be dz by dz dx. Okay, now to find out dz by dx, it will be equals to zx plus zy into dx, zy dy by dx. It has to be dy by dx. Okay, now zx will be equals to del z upon del x. So the differentiation of z with respect to x will come out to be, it will come out to be 18. It will come out to be 18x. Okay, so we have now here what differentiation of y will be 0 because it is constant. Now zy will come out to be del z by del y. So this will be equals to 7. Okay, 7. Now we have to find the dy by dx. So dy by dx will be, it has to be dy by dx, and dy by dx equals to, this will be 12x square plus 3. Okay, now put all the values in equation 1. So let me put it. So this will be dz by dx equals to 18x plus 7 into 12x square plus 3. So this will come out to be 96x square, and sorry, this has to be come out to 84x square. Okay, plus 18x plus 21. Okay, so this will be your answer. Now let's move to the next question. In this question we have z equals to 8x square plus 3y square, where x equals to 4t and y equals to 5t. Now we have to find dz by dt. Okay, so dz by dt will be equals to zx into dx by dt plus zy into dy by dt. Okay, so we have to find all these values. Okay, so first let's begin with zx. So zx will be equals to, here it will come out to be 16x, and zy will be equals to 6y, because here differentiation of dx by dt will be equals to 4 and dy by dt equals to 5. Okay, now let's assume equation 1 and put all these values. So we'll get dz by dt equals to zx, that is 16x multiplied by 4 plus 6y multiplied by 5. So this will come out to be 64x plus 30y. So now put the value of x. So this will be 40 and 30 into 5t. So finally it is coming out to be 256t plus 150t. So finally it is coming out to be 460. So this will be your answer. Okay. Now let's move to the next question. So this is question number 3. So in this z equals to 8x square plus 14xy plus 5y. Okay, so we have to find zx, okay, and we have to find zy. So here it will come out to be 16x plus here we'll take 14y as constant and x will differentiate x, so it will come out to be 1. Now for zy, we here x square differentiation is 0 and here it will be coming out to be 14x because we are keeping differentiating y, and this should be 5y square. Okay, so this will come out to be 5 to the 10y. Okay, so this will be your answer. So that's all from my side. And if you are preparing for IGIDR 2021 exam, so join us our Telegram channel by searching IGIDR by PTH, and you can also subscribe to our YouTube channel. And if you like this video, please share it with your friends and subscribe the channel. So thank you from my side. Stay safe, stay healthy.